Welcome to the DIY Honda Garage channel. Welcome to this presentation on Diagnostic Trouble Code P0966, which is related to the CVT, Continuously Variable Transmission Driven Pulley Pressure Control Valve circuit in the Honda CRV models from 2017 to 2022. This error may indicate a low circuit condition affecting the pressure control valve, crucial for the proper functioning of the CVT system. The CVT-driven pulley pressure control valve is responsible for regulating fluid pressure within the transmission, thus impacting the vehicle's ability to accelerate smoothly. A low circuit condition can lead to transmission performance issues, requiring immediate attention. Understanding this DTC is an essential first step in ensuring the reliability of your Honda CRV's transmission system. We will go in-depth into the various aspects of troubleshooting this code, examining potential causes and solutions, ensuring your vehicle operates efficiently. DTC P0966 indicates a low circuit condition in the CVT-driven pulley pressure control valve circuit. This component is critical for regulating the fluid pressure that helps the transmission perform optimally. It is located within the transmission assembly where it directly interacts with the other hydraulic components. The driven pulley pressure control valve's role is to ensure that the right amount of pressure is maintained for smooth operation of the transmission system. When this valve malfunctions due to electrical circuit issues, it may lead to driving disruptions or reduced vehicle performance. Therefore, thorough diagnostic checks and potentially repairs are crucial to maintain the vehicle's operational integrity. There are multiple possible causes for triggering DTC P0966, primarily related to electrical issues rather than mechanical failures within the transmission. The first and foremost potential cause is an electrical circuit problem, which suggests that there could be an open or short in the wiring connected to the CVT-driven pulley pressure control valve. A faulty pressure control valve itself can also trigger this code if it is not able to maintain correct resistance levels. Lastly, wiring issues or shorts can lead to incorrect signals being sent to the powertrain control module, PCM, resulting in a failure indication. Identifying the specific cause is essential to efficiently resolve the issue and restore transmission functionality. The symptoms associated with DTC P0966 can significantly affect driving comfort and safety. One of the most common symptoms is noticeable transmission performance issues, such as sporadic slipping or delayed shifts, leading to a less responsive driving experience. Drivers may also observe warning lights illuminating on the dashboard, indicating that a DTC has been logged, which is often accompanied by trouble code notifications like P0966. If left unchecked, these symptoms can lead to more severe damage or performance failures, emphasizing the need for prompt diagnosis and resolution. Recognizing these signs early can prevent further complications, ensuring that the vehicle stays in good working order. The first step in troubleshooting DTC P0966 involves problem verification. Begin by turning the vehicle to the on mode without starting the engine. At this point, clear the DTC using the HDS, Honda Diagnostic System tool. The HDS is essential for diagnosing various Honda vehicle issues, allowing for DTC management and system checks. After clearing, start the engine and wait for at least 1 second. Next, check for any pending or confirmed DTCs with the HDS. If DTC P0966 appears, you have successfully duplicated the failure, and you should proceed to the subsequent steps. If the code does not appear, it indicates an intermittent failure, requiring further investigation of connections or terminals between the CVT valve and the PCM. In this step, we focus on the CVT-driven pulley pressure control solenoid valve check. Begin by turning the vehicle to the off or lock mode to ensure safety while performing the checks. It's crucial to jump the SCS service check signal line using the HDS and wait for more than 1 minute. This protects the Powertrain Control Module, PCM, from potential damage during testing. Next, disconnect the PCM connector C, which has 51 pins. Measure the resistance between test points 1 and 2, specifically between pin number 10 and body ground. The resistance should fall within the range of 5.0 to 6.3 ohms. If the resistance is within this range, the solenoid valve is functioning correctly, and you should research authorized service information for any related DTCs or symptoms. If it's outside this range, proceed to the next troubleshooting step. The third troubleshooting step involves checking for any shorted wires within the electrical system. Begin by disconnecting the solenoid wire harness A8P connector for safety and to facilitate accurate testing. Ensure the vehicle remains in the off or lock mode during this process. Use a multimeter to check for continuity between test points 1 and 2, specifically testing from PCM connector pin number 10 to body ground. If continuity exists, it indicates a short to body ground in the DNLS wire connecting the solenoid wire harness A and the PCM. If a short is found, repair accordingly. If no continuity is detected, proceed to the next step to further diagnose electrical issues in the system. Step 4 centers on checking the internal resistance of the CVT-driven pulley pressure control solenoid valve. Start by disconnecting the solenoid valve 2P connector to access the terminals. In the off or lock mode, measure the resistance between test points 1 and 2, focusing on the male terminals within the solenoid valve connector. The resistance should again fall within the range of 5.0 to 6.3 ohms to indicate proper functioning. If the reading is within this acceptable range, you can move on to the next step for further investigation. However, if the resistance is outside of this range, it suggests a faulty solenoid valve, necessitating the replacement of the valve body assembly to restore proper function. The final step in the troubleshooting process requires determining if there are shorted wires in either solenoid wire harness A or B, particularly focusing on the DNC plus line. Start by disconnecting the solenoid wire harness B connector. This ensures isolated testing for accurate results. Again, keeping the vehicle in the off or lock mode, check for continuity between the specified test points. Solenoid wire harness A6P connector, pin number 2, and body ground. If continuity is found, this indicates a short to body ground in the DNC plus wire that requires repair between the solenoid wire harness A and B. If there is no continuity, a short to body ground exists elsewhere between the CVT-driven pulley pressure control solenoid valve and the solenoid wire harness B connector, which also requires repair. Accurate repairs in this step are critical to restore the function of the CVT system. After completing the troubleshooting and repair steps for DTC P0966, it's vital to conduct a final verification to ensure that the repairs made have resolved the issue. Begin by rechecking the DTC status using the HDS to confirm that DTC P0966 no longer appears. This step assures that all electrical connections are sound and that the solenoid valve is functioning properly. Following this, it's essential to perform a test drive of the vehicle, which allows you to monitor its transmission performance under actual driving conditions. Pay attention to shifts, responsiveness, and any warning lights that may appear. Completing this verification process validates that the repair measures were effective, ensuring the vehicle operates correctly. To minimize the chances of encountering DTC P0966 in the future, engaging in preventive maintenance is essential. Regular inspections of the wiring harness connected to the CVT and pressure control solenoid can help identify potential wear or damage before it becomes an issue. Additionally, keeping connectors clean and securely fastened ensures stable electrical connections, reducing the likelihood of circuit failures. Performing periodic system diagnostics using the HDS will allow you to catch issues early and maintain the health of your vehicle's transmission. Preventive actions can save time and money in the long run by ensuring that your Honda CRV maintains consistent performance and reliability. In conclusion, DTC P0966 is a critical error that directly impacts the performance of the CVT in Honda CRV models from 2017 to 2022. This diagnosis leads to potential issues stemming primarily from electrical circuit problems rather than mechanical failures in the transmission. Understanding how to troubleshoot effectively is essential to addressing such DTCs and ensuring reliable vehicle operation. Moreover, regular preventive maintenance plays a vital role in avoiding future issues and prolonging the lifespan of vehicle components. By remaining proactive, Honda CRV owners can maintain the integrity of their transmission systems and enjoy a smoother driving experience. Please like and subscribe to the channel. See you next time.